Hello there, welcome to the last lesson for Calc AB. We are going to focus on some final integration techniques, also known as a bag of tricks. Here are your bag of tricks that you're going to use to help you kind of solve and tackle those difficult integrands that are really kind of different than what you've looked at before or dealt with before. Okay, so I'm going to go ahead in this video, I'm going to go teach you about 3 different kind of tricks that you can go ahead and utilize when integrating. Okay, all right, so the first thing that we want to go ahead and do, looking at example 1, is you should notice that you have a denominator and you want to go ahead and treat that as a u. So let me say, okay, x squared plus 2x plus 1. If that's my u, what is my u prime? And I have 2x plus 2. Well, I have the 2x here, okay, but what I'm missing is that plus 2. So I can't go ahead and just integrate a 1 over u, or can I? Okay, so here they say adding or subtracting terms in the numerator is one trick that you can do, right? So you agree I can add 0 to something, right? And it stays the same. It's called the additive identity. Okay, well, if I add here, I add 2, I want to still add 0, so what I have to do, I have to subtract 2. Okay, so now what I've done is I've put in our hook. I have 2x plus 2 over x squared plus 2x plus 1 plus dx plus the integral of 2 over x squared plus 2x plus 1. Haha, do you see that trickery? So now what I've done, right, is in our first integral, I can go ahead and I can treat this, right, as the integral of 1 over u, okay, where u is the polynomial x squared plus 2x plus 1, okay, and I have the hook 2x plus 2 dx, okay, so that's going to go away, right? By, and we have the natural log of the absolute value of x squared plus 2x plus 1. All right, pretty tricky, right? That's why it's a bag of tricks. All right, next, I need to go ahead and work out this integral. Notice the denominator, I can go ahead and factor that, and I can factor that as x plus 1. So I have 2 times x plus 1, right? X plus 1 squared to the power of negative 2. So I just factored this and I brought it up, okay? And now what I have is just a simple power rule, right? The derivative of the inside is just 1, okay? So I have 2 times x plus 1, and I'm going to add a power to this, so this would be power of negative 1, and I'll divide by negative 1 plus c, and I'm done. Okay, so that is the adding and subtracting identity. Let's go ahead and check it out again for number 2. If I look at number 2, again, your u, a function in the denominator, is e to the x plus 1, and then the u prime would be the derivative of this, which is just e to the x. I don't have an e to the x. Okay, so what if I go ahead and I use this newfound trick that we have? I have 1 plus e to the x, and I can't just add whatever I want. I have to balance it, right, essentially. So I'll subtract an e to the x over e to the x plus 1 dx. So what good does this do me? Well, if you look here, don't you see that that's the same thing? That's essentially 1. So I have the integral of 1 dx, okay, minus the integral of e to the x over e to the x plus 1 d to the x dx. So now, hey, look, I have my u and I have my u prime for this function here. Hey, isn't life good? Okay, so this is the integral of 1 is just x, okay, minus the natural log of the absolute value of e to the x plus 1 plus c. And there you go. There you have it. Okay, I do want to teach you another method. So this is method 1 for this problem. There is a method 2 that you can go ahead and utilize that they've been talking about in the notes. So method 2. Okay, so here's method 2. Not only can I have an additive identity, right, which is 0. If I add 0 to something, it remains the same. I also have a multiplicative identity, right? So if I have something, let's say x, and I want to keep it the same, and you multiply, what are you multiplying by? Well, you're multiplying by 1. Okay, so can't I adjust this? Can't I go ahead and take my integrand, and I'm going to multiply the top by e to the power of negative x. Okay, so in this case, right, I'm multiplying by e to the negative x over e to the negative x. Now, why e to the negative x? I'll show you here in a second. So e to the negative x, okay, times 1 is e to the negative x over, and I'm going to multiply in here, so e to the negative x. Okay, and if I distribute this, e to the x times e to the negative x gives us e to the power of 0, which is 1, okay, plus e to the negative x dx. Okay, so why did you do that? What was the purpose? Well, like now my denominator is e to the negative x plus 1. Okay, that's my u, and then u prime is e to the negative x times the derivative of the power, which is negative 1. Hey, don't I have that? I just have to go ahead and I have to drop in a negative here and balance it here. But don't I have my hook? Yes, I do. So this is negative natural log absolute value of e to the negative x plus 1 plus c, and we're done. Okay? Now, note these look different, but it's actually the same answer. Believe it or not. All right? Okay. So next trick that I'm going to go ahead and teach you, and we've already kind of talked about this, it is a trig substitution. So when we look at example 3, we have the integral of tan squared of 2x plus cotan squared of 3x dx. And the thing is I don't have an antiderivative for these functions squared, right? So like I don't have a derivative of something that's going to give me tan squared or something that's going to give me cotan squared. But a little trick that we can go ahead and do is we can substitute in the trig identity that goes with them. So tan squared of 2x, okay, well that is equal to secant squared x minus 1, and then cotan squared of 3x, I can go ahead and substitute in cosecant squared of x minus 1. Okay, so we're going to go ahead and just do some direct substitution. So I want to integrate. This is going to be the integral of, so instead of tan squared, this is going to be secant squared of 2x minus 1. Okay, plus, now I'm going to go ahead and plus, instead of cotan, this is cosecant squared of 3x minus 1 dx. Okay, and I can just integrate piece by piece. So, I forgot my, well, I guess the parentheses don't even matter. I don't even need the parenthesis here. Okay, so I can go ahead and integrate this. In order to integrate the secant squared of 2x, I need a, well, I'm going to go ahead and, I'm going to split it up by parts. Secant squared of 2x, okay, dx. Now, in order to integrate this, I do need a hook factor of 2. So I'm going to drop in my 2 here and balance it with a 1/2. Okay. Minus the integral of 1 dx plus the integral of cosecant squared of 3x dx. And in order to integrate this, I need a hook of 3, so I have to balance it with a 1/3. Okay, minus the integral of 1 dx. Okay, and I can go ahead and integrate all of these. Very, very straightforward, right? So this is 1/2. Okay, what antiderivative? What's the antiderivative of secant squared? Well, that is tan. Tangent of 2x. Okay, minus x. Plus, okay, what's the antiderivative of cosecant squared? Well, that is cotan. So 1/3 cotangent of 3x minus x plus c. And there you have it. Pretty sweet. All right. The last trick I'm going to go ahead and teach you is involving negative signed areas of integrals. So when I want to calculate a definite integral, the signed area, remember if it's above the x-axis, it's positive. If it's below, it is negative. So example 4, they want us to set up an integral, and we don't actually have to integrate it. But of this function here, x squared minus x minus 6 from -3, okay, from -3 to 5, which is here. Okay, so I have this area underneath the curve, and I have this area underneath the curve, and all of that will be positive, so the absolute values don't apply there. But then I also have this area in the middle here, which is negative, and I want it to be positive. I want to go ahead and I want to essentially bring it up here, right? And I want to go ahead and make this area positive. So what trick can I do? Well, you can integrate piece by piece. Okay, so we're going to go ahead. I'm going to take this integral, okay, and I'm going to split it up. So it's the integral of our function from -3 to -2. So that first piece, x squared minus x minus 6 dx, okay? And then I want this area. Well, it's the same area, but it's negative. So can't I just make a negative a positive by multiplying by negative? And that's what I'm going to do. I'm going to subtract the integral from -2 to 3 of this function. I'm going to subtract it instead of adding it because it's negative. I want it to be positive. Hey, pretty sweet trick, don't you think? Plus the integral from 3 to 5 of the same function. X squared minus x minus 6 dx. And there you have it. That is it. All right, that's it for my bag of tricks for this video. In the next video, the last video, okay, I'm going to go ahead and show you the last couple of bag of tricks. Peace.